Well, this is the review for section 5-4, and our first task is to graph this using calculus. So let's find the derivative, f prime of x. And let's see, we'll use the quotient rule, so we'll square the denominator. And then we'll take the derivative of the numerator, and the derivative of that is 1, and we'll multiply it times the denominator, so that's 1 times 3 minus x is 3 minus x. And now we subtract, and we'll take the hold 2 plus x constant, and take the derivative of 3 minus x, which is going to be minus 1. So when we get that done, let's see, excuse me, I've got to put that square symbol out here. There we go. Now we've got it right. Make sure you change that. Okay, 3 minus x squared. And now we've got a 3 minus x. And a minus times a minus is a plus, so plus 2, and I can just drop these parentheses now. And it looks like the x's are going to add out, and we get 5 over 3 minus x squared. And notice that's positive everywhere, because the denominator is positive, 5 is positive, so it's f prime of x is greater than 0 for all the values in the domain. Let's find f double prime of x and see what the concavity looks like. So now again we square the denominator, so that's going to be 3 minus x to the 4th power, and now we'll take the derivative of the numerator, which is 0, and multiply it times the denominator, so that's going to be 0, then minus, and now we'll hold the 5 constant and take the derivative of the denominator, which is going to be, let's see, 2 times 3 minus x, and reduce the exponent by 1, which, so we get a 1 here, and then take the derivative of minus x, which is minus 1. And so now we have a negative times a negative, and that's a positive. And let's see, 5 times 2 is 10, isn't it? So we get a 10 times 3 minus x over 3 minus x to the 4th, And now keep in mind, I'm going to start over again right up here. So one of these factors of 3 minus x divides out, and we get 10 over 3 minus x cubed. And so f prime of x is greater than 0 for all x in the domain. F double prime of x, for f double prime of x, we'll do a number line. And it's undefined at x equals 3, so we'll put a 3 here and an open circle. And now, if x is negative, if x is less than 3, then this will be positive. If x is greater than 3, this quotient will be negative. Now we need to do one other thing, and we've got to do the horizontal asymptote, so we'll just take the limit as x goes to infinity, In fact, I'm going to make that plus or minus infinity because they both behave the same. And we've got 2 plus x over 3 minus x. And if we divide every term here by x, we've got the limit as x goes to plus or minus infinity. And I'm going to divide every term by x plus x over x divided by 3 over x minus x over x. This is going to go to 0. This is going to go to 0. This will go to 1, and that'll go to negative 1. So what we get is 1 over negative 1, which equals negative 1, and that's the limit as x goes to infinity. So negative 1 is our horizontal asymptote. Y equals negative 1, and we'll graph it. Okay, so now we have to graph this function, and I've summarized what we've found. That there's our function. The derivative is positive for all the values x in the domain, and the domain is all reals except 3. And the second derivative is positive for values of x less than 3 and negative for values of x greater than 3. Also, we've got a critical point at x equals 3 because it's undefined there. And we've got a horizontal asymptote at negative 1. So let's go ahead and do a graph. And let's see. So we've got a vertical asymptote at 3 because it's undefined for x equals 3. We've got a horizontal asymptote at negative 1. 0, negative 1. And so, well, that looks like a D, doesn't it? 1.
Hey, how are you?
There we go.
Oh, just good.
And now let's find what the y-intercept is, and that'll tell the tale as to how to graph it. So we'll look at f of 0 equals, and letting x be 0 in each case, we get 2/3. So 2/3 is about right there, and I'll just call that, let's see, 2/3 and 0. Oh boy. And that's that point right there. Also, let's find the x-intercept, and f of x equals 0 at, and all we have to do is inspect the numerator of this, and that numerator will be 0 at x equal negative 2. So we'll go over here to negative 2, 0. And now we can graph it. Let's see. There we have it. And so the rest of the graph will be in the opposite quadrant. And notice, it's the slope is always positive, and it's concave up on this interval from negative infinity to 3, and it's concave down, so the second derivative is negative, on the intervals from 3 to infinity. And I think we have it.